In this section, we're going to be learning about area of quadrilaterals. This includes area of parallelograms, trapezoids, rectangles, squares, and rhombuses. So keep in mind that when we talk about quadrilaterals, there are two main types. There are trapezoids and parallelograms. So let's start with parallelograms. Parallelograms are made up of bases and heights. Bases are actually the sides. In this particular picture, we have a base here and a base here. These are the two sides that are parallel to each other. Those are considered bases. We also have another pair of bases since we have two pair of parallel sides. This side and this side are also considered bases because they're parallel to each other. So we have two pairs of bases, where bases are the two sides that are parallel to each other. Height is the perpendicular distance between the two bases. And this will be the case with any figure. Height is always that perpendicular distance between any two bases. So we actually have two heights in any parallelogram because you have two pair of bases. I could also draw a height that's perpendicular to these two bases. It's a little harder to draw sideways like that. But there are two heights because there's two pair of bases. Now a base could be drawn inside, or a height could be drawn inside your parallelogram or outside your parallelogram. It doesn't matter. As long as that line is perpendicular to two bases, it is considered a height. So you can see here, this height is perpendicular to that top base and the bottom base. In the third picture, our height is perpendicular to the top base and the bottom base as well. So the area for finding a parallelogram is base times height. So if you know the length of one of your bases and the length of your height, you just multiply those to find the area. So in our first example, area equaling base times height, we're just going to multiply 6 times 4. So area equals 6 times 4, which is 24. Since we're dealing with area, which is how many squares can fit inside of something, this is 24 centimeters squared, or 24 square centimeters that will fit inside of our parallelogram. Therefore, our units are squared. So a parallelogram also includes a rhombus, a square, and a rectangle. So we now know our formula for all of those. The other type of quadrilateral we've studied is a trapezoid. The trapezoid formula comes from parallelograms. So let's look at this example. Here we have a parallelogram, this big figure, that is split into two congruent trapezoids. So if we consider the top of one of our parallel sides and then the other parallel side, we consider those two parallel sides bases. So we would have a height, which is the perpendicular distance between those two bases. So here's our height. It's always the perpendicular distance between two bases. Next, if you look at our trapezoid, we can split that top base into two different bases of two different lengths that add together to give you the whole base. And you'll notice that this first trapezoid is the exact same as the second trapezoid flipped upside down. Therefore, if the first base 1 is on the bottom of the first trapezoid, then base 1 would be the length of the top of our second trapezoid here. And if base 2 is the top of our first trapezoid, then it becomes what in the second one? The bottom, right? So here's base 2. So base 2 plus base 1 gives you the entire base of your parallelogram, whether you're looking at the top or the bottom base. So, since we know that a parallelogram's area is base times height, parallelogram's area is base times height, let's think through what a trapezoid's area would be. A trapezoid's area is going to be half of the base 1 plus the base 2 times the height of the trapezoid. In other words, it's half of the area of a parallelogram. But since the two bases in our trapezoid, since the two bases in our trapezoid are not congruent, we can't just say 1/2 base times height because the bases are not the same. So what we're going to do is say 1/2 the sum of those two lengths, because we have figured out that base 2 plus base 1 is the entire base of a parallelogram. So it's half of base times height, only our base is going to be base sub 1 plus base sub 2, because the entire base of a parallelogram would be adding those two bases together. So it becomes 1/2 of the sum of the bases of a trapezoid times the height. In a trapezoid, the bases are the sides that are parallel. Bases are always two sides that are parallel. So that's how we recognize them. So let's move on. So here's your basic trapezoid. This one is an isosceles trapezoid, but this will work for any type of trapezoid. In this case, we see our base 1 is the top base, our base 2 is the bottom base. Of course, we could twist this figure so they're not necessarily on the top and bottom, they're just the two parallel sides. And then the height is the perpendicular distance between the two parallel sides. So bases are always parallel to each other, and height is always perpendicular to the two parallel sides. The formula for the area of a trapezoid, which you need to know, is 1/2 times the sum of the bases times the height. So let's figure out how to find the area. So here's a random trapezoid. One of our bases is 14 and one of our bases is 8. It tells us that the length of this side is 10, but our height is actually going to be 8 because it's the perpendicular distance between the two bases. So the 10 is irrelevant information. So I'm going to use my formula. Area equals 1/2 the sum of the bases times the height, the perpendicular distance between the two bases. So area equals 1/2 times 14 plus 8 times 8. So now I just put that straight into my calculator to get area equals 88. And it would be units squared. Let's look at our next example. In this example, we use the same formula. Area equals 1/2 base 1 plus base 2 times the height. In this case, our bases are going to be 3 and 5 because those are the sides that are parallel. So area equals 1/2 the sum of the bases, 3 plus 5, and now we need to identify the height. Which one do you think is the height? Our height is 4.5 because that's the perpendicular distance between the two bases. So 8 and 10 are extraneous information. We're going to type this straight into our calculator. Remember to include your parentheses. Which gives you 18. And it would be units squared, centimeters squared, whatever your units are. Now rectangles are a type of parallelogram, so we could just say base times height. However, with a rectangle, the bases are the same things as the lengths, and the heights are the same thing as the widths. So our area does equal base times height. However, they call it length and width with a rectangle. So you learned that the area of a rectangle is length times width. The length and width of our rectangle are perpendicular to each other. So that's why the length and width are also the base and height. So you could use either one of these formulas. With squares, our sides are all congruent. So again, you can use the formula area equals base times height, but since base and height are going to be the same, the formula that's used is area equals side squared. Again, you could use base times height and it would work. So here are the formulas that you've learned so far, your basic formulas. Parallelograms, the area is base times height. We also have the length times width for a rectangle. We also have side squared for a squared. Rhombus, you're going to have to just use base times height. So we see our square there. Circles, the area for a circle is pi r squared. Circumference of a circle is 2 pi r. And then trapezoids, the area of a trapezoid is 1/2 base sub 1 plus base sub 2 times height.